So really, yeah, I want to talk about putting the web into WebRTC. It's really about putting some web thinking into how we do real-time communications. Kind of following up on what Danny was saying this morning, that is the way that we think the future may take us. And so I want to talk about some experiences and some tools that you might want to try and use. I'm Steely Glint on Twitter. I'm Tim Panton in real life. And for reasons I will explain over a beer, my business card says I'm a protocol droid. So, as I say, it says I'm a protocol droid. I'm a WebRTC fan. I have been since before it was a thing. We did, some of you may even have seen me doing a Java-based EEX soft phone in the browser some decade ago, probably now. And so I've been doing browser-based real-time communication for a while. I'm interested, obviously, in standardization because that's the way that you get volume of use, you get acceptance. That was always the problem with the Java thing. It wasn't really that standardized, although EEX got its own RFC. Anyway, so I'm interested in standards. I've been working with the IETF to try and get standards done, and I've been quite active in the WebRTC standardization. I'm currently doing my own thing with IoT, and in the dangerous demos section later you should, with any luck, get to meet a couple of my IoT projects. I will give you a little teaser here. This I'm calling Al, and she's a girl, and she has a voice, and you can guess, maybe, whose voice she has. So, let me put Al away before she does something regrettable. So yeah, and at the moment I'm doing my own thing with IoT, but I'm also doing a bit of consulting. So I wanted to follow up on what Danny said, although to some extent he's stolen this slide. Change is coming, change is happening, and it's happening fast. And I wanted to look back at how amazing those sorts of changes can look when you look back at them. So if you think about physics, 1905, Newtonian physics was absolutely the accepted doctrine. Everyone assumed that I mean, it covered all of the base cases people were interested in. You know, we used it to get to the moon, so there's nothing wrong with Newtonian physics, but there were just a couple of little edge cases which didn't quite work, you know. The photoelectric effect, for example. And this guy, Einstein, had a look at the photoelectric effect, and the more he dug into it, the more he found that there was more to physics than had been thought. And it turns out that there's a quantum universe kind of underneath the Newtonian approximation. And it opens up a whole pile of possibilities. And we've spent the last 110 years, since 1905, working out what to do with those possibilities. And, you know, the transistor is an example, but there are an infinite number of applications now of the quantum physics. So I'm claiming, and this is a broad claim, but I've been making it for 3-something years now, and it's getting less outrageous, that WebRTC is like that, in that it is at least a catalyst for a set of changes in the way that we do communication. It changes the baseline, it changes the possibilities of what we could do. And the key things that, from my perspective, it adds are that it does peer-to-peer, it does it securely, and it allows you to add context. But it's also on the web. So the old way, we all know, you did calls per minute. Now this phone, actually, I stumbled over it. This is a payphone in a Berlin bar, East Berlin bar, and you literally put pennies, or pfennigs actually, into this thing, and you make calls. Those days are gone. It's not actually even about calls anymore. I don't know if you heard Billy talking about Twilio planning to do 1 billion WebRTC minutes this year. But what's interesting about those minutes is they're not necessarily calls per se. They're extensions to applications. So there's a really good example of Uber. So Uber and I think Lyft had this battle going on in New York. And basically Uber were using the fact that if you booked a Lyft ride, then you got issued the driver's phone number as a side effect of booking that ride, which you could then cancel, but you still had the driver's phone number. So what Uber were doing is booking these rides, getting the phone numbers, cancelling them, and then ringing the driver up saying, I see you're getting a lot of cancellations with Lyft, why don't you come and work for Uber? Which was to do with the fact that we're using a single unique identifier, i.e. the driver's phone number, as it's kind of like the social security ID. It's spread everywhere, and it starts to get vulnerable. And what Uber would like to do, and what Lyft will need to do, is to bury the communications as part of their app to tighten that thing down. So it's not just about user experience. User experience is obviously better if it's an integral part of the app rather than stepping out to a dialer. But it's also about the business. That you can protect your data, you can protect your customers, you can protect your suppliers by making that access, those IDs, private and managing them yourselves. And it's still communication, but it's to do with the context that you're in. I don't necessarily want an Uber driver to have my phone number forever. I might get on fine with them, I might not, but that's not a thing I necessarily want them to have. I do want them to be able to contact me and say, where are you? I'm outside, wherever. And the same's true the other way around. So it's all about the context, and the call is a secondary issue. It's to do with how do you achieve, the whole thing is how do you achieve a goal rather than, which in this case is getting a lift somewhere, but it isn't about making the call. The call is a subsidiary way of me achieving that. So, having said that, the thing to do is not to underestimate what you can do in JavaScript. I've talked about context and cookies. There's an awful lot you can do there, and I'll do maybe one little demo of that. But there's also some fantastic APIs which you may not be wholly aware of and that you can do cool stuff with. Obviously WebRTC at the bottom, I'm sure you've heard far too much about that. There's WebGL, which basically lets you do a full set of graphic rendering in a reasonably clear language in JavaScript in real time. And it's a fairly simple language which you then push down into an interpreter which goes off and does the heavy graphics. And it's reasonably well optimized against the hardware in most people's phones and laptops. So it's not like you're actually bit pushing in JavaScript, although you can if you have to, pixel pushing. And WebAudio is the same sort of thing, but for audio. You have basically a lot of capabilities for handling audio in the browser now. So talking about context, the context is essentially, setting up a call is about establishing a shared context. It's how we get from the thing we're trying to do to bring in other people to help us complete that task. So it's around who am I, and who do I want to, who can call who? Can I call you? Can you call me? Does the system want to do that? Do I want these people to randomly call me? Well, actually, generally, I don't. I'd rather have a discussion in text first about, as Dan York was saying yesterday. I'd rather have a discussion in text first, which may be part of an app, or it may be a scheduled meeting that I've booked a meeting with these 5 people. But basically, there's a whole lead-in process to the live call now that you have to factor into this. Unexpected live calls are generally bad news. Like they're the hospital calling, they're the daycare saying your kid is sick. They are, and actually, or there are people trying to prank you and rip you off. So it's very rare that there's a live unexpected call that is one that you want to receive. So talking about context, I said login and cookies is one way, and there's for a business app that makes sense. You log in, it sets a cookie in your screen, and you use that throughout as a session control for the rest of your session. But there are others. An example which I won't do because you'll just get feedback, but there's a peer in. So if I were to browse to that URL and 2 or 3 of you were to browse to that URL, we'd all be in the same conference room. So the URL is a hook around which everyone can join in. And there's no sessions, there's no cookies, there's no logins, there's no nothing. It's just if you know that URL and you know when I'll be there, you go visit. So I had an app which I can describe. I might show you later, depending on how the time goes. But it's basically around how do you do security for your pets. So if you want to do a video call to your pet, You leave an old tablet there and you put it on auto answer, and yeah. The problem is that it'll auto answer to the thieves and liars and random people, and the pet isn't able to reject the call. It certainly isn't able to log in as an ID. So you have to have some mechanism for protecting that and narrowing down where those calls can come from. And what the YoPet thing does is to pair up WebRTC devices. And I may demonstrate that later depending on how the time goes. So I want to talk now about WebGL. WebGL, it's a video effects, real-time video effects. So it's not just static images. This can be real-time video as well as image. And it's built into the browser. And it's in most of the browsers now. So this is seriously.js is a really nice set of filters, open source filters in JavaScript, which you can apply to videos. So this is seriously. Now, let's do it. So what you have here is a guy with a green screen, and then you can layer in. I've deliberately muted him because it's fairly profane. So he's behind a green screen, and then I can apply in real time in my browser locally. This isn't processing off on the net somewhere. This is all being done on the browser. I can apply a fish tank background, or I don't know what. Yeah, it's a kind of submarine, or I'm not quite sure what Spirit is. Oh yeah. A whole black and white filter thing. And this is in real time. This is in my browser. This can be, and although this is stored video, it could equally well apply to WebRTC video that's going past. But of course, this is my favorite, the British invasion. James and I are actually the British invasion. So, and Dan. So, so that you can do that in real time in your browser, and you might ask whether there's any point to that, but it could liven up the odd video call. So let's get rid of that. Now, this is another one. This appears to be a completely boring get user media thing, but with any luck, if I get myself in the right position, we can virtual reality a picture onto my chest. Now, again, real time in the browser, and you wonder whether there's any point to that, but think of this. Imagine if you did this to a sports team, and as the guy is about to score a goal, you auction off the image on his shirt to advertisers. You could get into a bidding war real fast like that. Now, these images are, as far as I understand, they're copyright free because they're so old. That's why they're black and white. And it's also why they're stills. There is no reason why that shouldn't be a moving image. So again, you have to be quite imaginative to think about how you might possibly use that, but it's amazing that those technologies are just loafing around in your browser right now. Every single one of you with laptops have this capability in Chrome and Firefox. And I don't think it's in Safari, but one would have to check. The WebRTC aspect of it certainly isn't. So I will stop distracting you with this. And back to this. There we go. So, and as I say, it's a bit pale now, but these slides will be available. You can look these URLs up. Both of these things are open source and hugely extensible. So, and can be applied to remote video streams as well. So, am I feeling brave? How brave am I feeling? Anyone up for fear? Okay. So this isn't. I had to get this thing onto the local Wi-Fi. So I explained the YoPet problem, which is your pet is basically unable to. Why am I not on the? Maybe I am. Let's see. I am. Excellent. So the deal with YoPet is that you want to permanently pair a device or two devices, an owner's device, an owner's endpoint. And so we'll forget this. So let's pretend we've just got these two, we're just starting this relationship up. Let's see whether right. So the deal here is, when you start the YoPet, the pet's end, it shows a QR code. When you start the owner end, it does a get user media. It's going to get confused by this, so that's going to be interesting. And when they see each other, so effectively you have a quite nice out-of-band pairing. So this is an out-of-band transfer of a key, basically, from one to the other. They now are paired. At which point,
I'll be your pet.
yes, James is going to hold that. He doesn't need to press anything, and with any luck, when I click video on, we should go into a WebRTC video call. And he didn't press anything, and I'm in control of this. He can't call me, but I can switch him off. But the point there is that it's a secure endpoint that's been paired using actually WebGL and get user media to grab the QR code. The QR code decoding is actually mostly done in JavaScript, which is amazing what you can get done in JavaScript. So, and I should warn you, I filed a patent on the particular token that I used there. I haven't described it, so you're not, if you don't choose to look at it, that's your business. I know the Digim folks in particular don't like knowing about patents if they don't have to. The details of this are actually in an IIT talk that I gave in Chicago last week. Feel absolutely free to email me and I'll send you a link to that talk. But again, I'm kind of being a little evasive for your reasons, not mine. So basically, what the patent allows you to do is to create a federated relationship without trusting the middlemen. And that's the trick of this thing, which is kind of relates to what Matthew's going to speak about next, but it doesn't actually use any of the same techniques. It kind of achieves a related purpose, but in a different way. So, moving on to WebAudio. WebAudio is the same sort of thing as in terms of kind of programmability of media, of real-time and near real-time media, but it's for audio. And it's basically like having a late 80s synth in your browser. So if you think about the plug board where you took the oscillator output and you plugged it into the sawtooth gain control and you did, put it through the reverb and then you mixed it with the other input and and you output the whole thing to the speakers, all of that, and actually in a pretty similar kind of metaphor, is available in JavaScript in your browser right now. So, literally actually, so here is, in JavaScript, a synthesizer, and that's in JavaScript in your browser, and there's nothing to stop you from controlling that over, say, the WebRTC data channel remotely. I mean, it's in the browser. All of the rest of the browser tools are available to you. It doesn't have to, be a keyboard. It could be something else. And so, I seem to have many of these now. Oh yeah. Ha. And I was saying, it doesn't actually have to. Doesn't have to look like that. It doesn't have to look late 90s. It can late 80s. It can look thoroughly modern, and you can still do the same sort of thing. Now, this I particularly enjoy. This one. This is my favourite effect. Apparently, you can make it sound like a parking garage. Or a lodge, deader, presumably, or a cave. Anyway, point being, that's all in your browser. That's something that you can. So you could add those effects to your calls. Your on-hold music could be automatically generated, but it could be done locally. So, in terms of what you've got available. You can plug WebRTC into WebAudio. So Chrome only supports, this is slightly asymmetric, so I should warn you, Chrome only supports outbound WebRTC streams from WebAudio. So I could generate that synthesizer and I can then send it to the far end. But when the far end comes back with something, I can't then mix it at this side in Chrome because the inbound stream isn't available to WebAudio. They haven't done the plumbing underneath to allow that. Firefox, on the other hand, have. So in both directions, you can do WebAudio manipulation of real-time streams. And I might add, actually, I didn't say this earlier, but Firefox have recently released a thing that will allow you to do the same thing for video. So you can paint your incoming video stream onto a canvas, manipulate it in WebGL and display it, which is reasonably obvious. But you can also, in Firefox now, do the other thing. You can paint on a canvas and then say, use that as your WebRTC media source, and then throw that over the wire to the far end. Sorry, coming back to WebAudio, you can process your audio before sending it in Chrome. You can filter delay. The core features are filter delay, fast Fourier transform, and convolve, and obviously mixing. And those things can then be plugged together in a kind of plugboard sort of way. You can do things like, you can use the fast Fourier transform to do a spectrum display, or filter out, the hum from the machinery, or the hiss from the infrastructure, or whatever. And if you're feeling clever and brave, then you can do arbitrary maths in a web worker. So you can create a buffer of data and generate it and send it off to do arbitrary maths. If you're feeling super arcane, you could probably do crypto on that. So you could send an encrypted media stream, and then there is a demo which I sort of hesitate to mention because it's borderline offensive, but it's some clown has written a 1200 baud modem in WebAudio. So you can implement, I actually tested this and I couldn't quite get it to work, but in theory you could call a fax. But I've seen it work for a BBS. So you can call a BBS from WebRTC and then get the 1200 baud back and get the welcome to, CompuServe or whatever modem thing from the late 90s. Frankly, that is of no use to anybody, but it's amusing that you can do it. And the next logical step is to combine these two and do a fax modem, so that you could take a fax transmission and render it, and then you could do it the other way around. But really, please don't do that. So yeah, and in Firefox you can do that symmetrically, but you couldn't do a fax modem in Chrome, so it's not practical. So now, this has all been a bit kind of fluffy and foolish, but actually I used this stuff. I was doing a contract for Wire in Berlin for a few months, and we were testing group calls and point-to-point calls in WebRTC. And well, actually this is true for VoIP engineers in general. We spend an awful lot of time talking to ourselves. So you pick up the phone and you pick up the other phone and you tap this one and hello, am I there? Yes, yes. That actually, in an office with web developers, you get some really strange looks. So I got to the point where what I could do was inject audio into the call. So I could set up the call silently and then press a WebAudio button which would inject into the call some audio, and then with the headphones I could hear it coming out the other end. So, and the nice thing about that was it bypassed the AGC and the echo canceller. So I was kind of testing the signaling and the media layer without going right up into the browser. Now, I wonder if I have time to do this. Oh, what the heck. So this takes a little setup because I need to make have two calls. So this is I don't know if any of you used Wire. Its two key features are that it's pretty and that they're interested in security. So they do, you know, they try quite hard on the technical audit of so that's one side, and now we need the other side, which it's Bodhi. Gosh, yes, and Dan's going to cause trouble now. Thank you, Dan. So let's do this in separate browser with my fake identity. No, got an L in there. Don't want an L. There's nothing more boring than watching me type badly. Well, actually there is, which is typing badly whilst people are watching. Yep. Okie dokie. Right, now. Oh, why not? Right, so, call myself. So if I place a call to myself and I'll mute that, and I will allow that, and I will allow that, and I'll mute that. So now we have a muted call between two ends, and the cute thing is, in the JavaScript console, I should be able to go
0.
So I can inject audio from the Chrome console.
0.
And actually, you have to take my word for this. That is coming out of the Firefox receive end. So if I hang the call up, you won't hear it. That's the kind of best proof I can do for you. In fact, I think it'll probably reject it because there's no active call. Yeah. So that's actually a really useful thing you can do. That's a practical thing that as voice engineers working on WebRTC you can do. You can actually save yourself from looking like a complete nutcase, which is, you know, for me that's worth having. So now. So what does that look like? You know, I've been talking about how easy it is, but I thought I'd show you a bit of code. So this is actually CoffeeScript, which is fractionally easier to read than JavaScript, but pretty much the same sort of thing. So what we're doing here is, this method is called when you get a WebRTC stream allocated. So it calls, you get something back from GetUserMedia with a stream in it, you call this method, and it takes the stream and it wraps it in a WebAudio context. Which means that, you create a context, you take your local source, you turn it into something that WebAudio can deal with, and then you take WebAudio and you create a destination, you can layer in some effects, and then you return to the rest of your WebRTC code base something, this stream, which is actually here at the bottom, that you return that stream to them. And as far as it knows, that's the stream it gave you. I mean, its properties are exactly the same, except that it's been through your effects, whatever effects you've plugged into that that list. So, and here's how you suck in an audio file. So this is just there's the usual kind of slightly backwards thing about how you have to write JavaScript. So actually, the active thing is at the end, and these are down here. That's the thing you're actually doing. And then here are the methods that will be called on load or on fail. And when it's loaded, then you create an audio buffer. And when it fails, you grumble. You know, so actually this is pretty usable JavaScript. And it's not huge in order to load in. And now I want to send a thing. It's the same kind of thing, only running effectively backwards. And then this is wrapping the inbound stream from the network. Same sort of thing, but it only works in Firefox 39 and above, which is now released, so Firefox in general. Unless you happen to be on, is it Red Hat has an older Firefox version? But anyway, most of them this will work with. Oh yes, and if you like graphics, I should have done this earlier actually. If you like graphics, this has, in the web developer, in the web console, there's a WebAudio chunk. So if we reload this page, and then do this call again, what you should see, if I can still find it, is a series of WebAudio pipelines. So this shows how the pipeline is constructed and how I've put it together. So in this case, there's actually only a gain control and a panner. I haven't done anything very complicated. But what's nice about that is you can actually start looking at the properties of it. So you can interactively see how this is put together in a quite kind of user-friendly sort of way. So that again, that was really useful when I was working on the wire stuff, and I suspect that it will be useful for some of you if you end up doing WebRTC work. So the other thing I did at Wire was to calculate latency, the audio latency of a round trip. And again, I mean, I'm not going to go into a huge amount of detail on this, but basically you can do this by creating an audio signal in Firefox, routing it out through whatever it is your device over the network to your device under test, and then having the Firefox microphone close enough to the real device that it can hear it. And then you just do some maths in JavaScript to work out what the latency between the two is. And actually turned out to be quite a nice way of doing it. So that was nice. So in the longer term, and particularly for this crowd, I think you should think about the fact that WebAudio in particular is now rich enough to do most of your IVR transactions. So instead of routing people into your calls, your asterisk immediately, you could do the IVR locally in the browser with much higher quality audio. And then once you've finally got to the point where you really need to speak to a call center agent, then you place the call into the call center. So you could do an awful lot of this stuff locally. And to an extent, this is more network resilient in the sense that if it takes a second or two to load the MP3, at least it won't stutter. So you'll be able to, it'll just take slightly longer to arrive and play out. And it'll get cached and stuff like that. So you know, you've got a lot of the web stuff on your side there. And the other, so you get less dial plan as well, of course. And there are a million web devs out there. And they're a lot easier to find, as Dan was saying yesterday, they're a lot easier to find than, and they like the idea of WebAudio because it's kind of new, hot stuff, which is not the feel that anybody has about the dial plan, I don't think. So the summary, the kind of too long didn't read is, the web browser has a bunch of rich APIs which are increasingly able to interact with WebRTC and real-time communication. Use them to delight your user. This is what your goal should be. It should be to make your user happy, to get your user to complete the task they had in mind as soon or as cheerfully as possible, instead of trying to rack up longer and longer calls to get the minutes. Or you can use them to make your life easier, which is what I did with the testing. Or you can do both. So yeah, I'm Tim Hansen, Steely Glint on Twitter. And yeah, no, thanks to Wire for letting me put all that on there.
Okay.